Okay, so now we're ready to try a kind of specialized form of covalent compounds here. These are hydrocarbons. Basically, this is a little bit of a preview to organic naming. Organic chemistry obviously is, a big class in college, and we're barely touching the surface here. There's really a lot more involved with organic naming, but we're just going to kind of do a few of these groups here just so you can get a taste of some organic naming. So first of all, these are all hydrocarbons. They all have the elements carbon and hydrogen in them. So like I said, it does have two nonmetals in them. So you might think at first like, oh, this is covalent naming, but you have to recognize that if it has just C and H in it, it's a special form of covalent naming. It's organic naming, so you have to name it according to the rules we're going to go through. So there's three different groups we're going to look at: alkanes, alkenes, and alkynes. And the names are similar, and you'll see what each of them are here in a little bit. But these guys also use prefixes, and you got to be careful because some of these prefixes are different from covalent prefixes, and some of them are the same as covalent prefixes. So you really got to be careful here and make sure that you're paying attention, like that this is organic naming and I have to use specific prefixes, which might be different from covalent. So the first four are the different ones. So it's all based on the number of carbons here. All right, so the number of carbons in your formula for these hydrocarbons tells you which prefix to use. So the first four are different from covalent. Okay, so if you have one carbon, it's the prefix meth, two would be eth, three would be prop, and four would be bute. And then it's just the exact same prefixes as covalent naming. So you do need to know these prefixes and you do need to be careful here not to mix them up. Okay, so we're going to start with the alkanes first. All right, we know that all of these organic compounds, all these hydrocarbons have C's and H's in them. Okay, but you have to pay a little bit closer attention to the formula because that'll tell you which kind of organic or which kind of hydrocarbon these are going to be. So the first thing you need to realize here is if you look at your formula and you see the number of carbons, you say, okay, well, if I have a certain number of carbons, how did I get the number of hydrogens from that number of carbons? If you took the number of carbons times that number by 2 and added 2 to it, and that's the number of hydrogens, then you have what's called an alkane. These have all single bonds in them. You don't need to worry about bonds yet. That's coming in bonding eventually. But to name these, you use the correct prefix. So remember here on the previous slide, we have to pay attention to the number of carbons. That tells us which prefix to use. But because it's times 2 plus 2 for the hydrogens, then it would end with ane. Okay, it's an alkane, so it ends in ane. All right, and then if you're doing the formula here, you would have the name written out. So the prefix tells you how many carbons to write, and then you would do the math. You would see the ending is ane, so you would need to know, oh, I need to take the number of carbons times 2 and add 2 to that in order to get the number of hydrogens. Okay, it might sound a little confusing right now, but guarantee you when you see some examples here, you'll be like, wow, that makes a lot of sense, and it's actually pretty easy. So let's jump right in here and do this first example. We want to name the following compound here, C3H8. Okay, so the first thing that catches my mind is, okay, yeah, there are two nonmetals here, but I see C and H only. So I should be saying, okay, I know I need to name this like a hydrocarbon, like an organic compound. All right, so the first thing I do is I look at the number of carbons. There are three. So that tells me I have to use the prefix for three carbons. Remember, these prefixes are a little different from covalent. The prefix for three carbon would be pro. So I immediately know the prefix here. And then what I do is I look at the number of hydrogens. There are 8 hydrogens. So I would say, okay, how did I get the number of hydrogens here from the number of carbons? Well, the only way I could get 8, okay, the only way I could get 8 here is if I took the number of carbons, which is 3, times it by 2, okay, which would be 6, and add 2 to it. Okay, so that makes this compound an alkane. So I would end it in ane. So this would be propane. Okay, so you have to remember, you have to look at the hydrogens and analyze them. How did I get that number of hydrogens from the number of carbons? So now if we reverse this here, and we're going to do the formula for butane, all right? So as soon as I see that it's ane, I immediately know without even thinking, I write down C and H. I know that it has to have the elements C and H in it. I look at the prefix, which is bute. That tells me the number of carbons. Bute is 4. Okay, so because it's an ane, I know all alkanes for the hydrogens are times 2 plus 2, okay, for the hydrogens. So you compare it to the number of carbons. So if I take 4 times 2 plus 2, there must be 10 for the hydrogens. And that's how you do alkane names and formulas. You really do need to pay attention to your prefixes and the math here you need to do, the times 2 plus 2 to get the number of hydrogens. So now we're going to do alkenes here. And I think since we did alkanes already, this should be a little bit easier. All right. So the first thing you notice here is that alkenes have the generic formula CnH2n, meaning the number of hydrogens is just times 2 the number of carbons. All right. Alkanes had times 2 plus 2. Okay, so this is a little different. These guys all have a double bond in them. Again, you don't need to worry about bonding yet. That's coming up here eventually. So to name these guys, it's very similar to alkanes. You have to use the correct prefix. So the number of carbons tells you which prefix to use. But once you see that the hydrogens are just times 2 the number of carbons, you know this is an alkene and has to end in ene or ene. All right, and then the formula is the exact same way as before. You basically use the carbons to tell you which prefix to write, and then because it's an ene, you would need to take the number of carbons and just times 2 to get the number of hydrogens. So if we do these examples here, all right, C6H12, all right, so the first thing I notice here is that there are 6 carbon, so the prefix for that would be hex. Okay, and then I look at the number of hydrogens. So to get 12 from 6, all I did was take 6 times 2. So that tells me this is an alkene because alkenes hydrogens are just times 2. So I end this in ene. This would be hexene. Now when I do the formula here for decene, all right, as soon as I see that ene ending, I know immediately it's going to have C and H in it. All right, and then the prefix tells me how many carbons. So if it's des, that's 10. All right, and then ene tells me to figure out the number of hydrogens, I just take the 10 times 2. So it's C10H20. So that's alkenes. Okay, so now we're going to do the last group of hydrocarbons, or the last organic naming here. So these are alkynes. These are different because the hydrogens are figured out by doing times 2 the number of carbons minus 2. All right, these guys have a triple bond in them. So in order to name them, you look at the carbons to get the prefix, and then you compare it to the number of hydrogens, and the hydrogens would be times 2 minus 2 the number of carbons, and then you would know, okay, this is an alkyne, I have to end it in YNE. And then in order to do the formula, it's pretty much the same as we've been doing. The prefix tells you how many carbons, and because it's a YNE ending, you know you need to times 2 minus 2 for the number of hydrogens. So for the first one here, we got C5H8. All right, so the 5 for the carbon tells me the prefix to write. So the prefix I'm going to use here is going to be pent for 5. And then I'd say, okay, well, how did I go from 5 carbons to 8 hydrogens? Well, I would take 5 times 2, that'd be 10, but then I minus 2 to get 8. So that tells me this is an alkyne, so it ends in YNE. This is pentyne. Then when I do the formula here for octyne, okay, as soon as I see the YNE ending, I immediately know it's going to have C and H in it. Oct tells me that there's going to be 8 of the carbon. And then if it's YNE, I know I have to times 2 minus 2. So 8 times 2 is 16, minus 2 would be 14. So the formula here for this would be C8H14. Okay, so now we're ready to try some more examples here. Again, you're more than welcome to pause the video and try these and then come back and see how you did. All right, so for the first two, I'm going to write the names of these compounds. I see C and H. As soon as you see C and H, okay, you need to think, okay, this is not just covalent. This is not just two nonmetals. It's a special form of covalent. If it has C and H in it, I need to name it like an organic compound, okay? So remember here, the number of carbons tells you the prefix to write. So in this first example, CH4, there's just one carbon. So the prefix when there's one carbon is meth. Okay, remember these are different prefixes from the covalent. The first four are different from covalent naming. All right, and then I say, okay, well, if I had one carbon, how did I get 4 hydrogen? So I must have taken that 1, times it by 2, which would be 2, and then I added 2 to get 4. Okay, times 2 plus 2 is an alkane. So this has to end in A and E. So this would be methane. Okay. When we do the next one here, C7H12. All right. So the 7 tells me the prefix. This is going to be hept. And then when we do the hydrogen, say, okay, well, how did we get 12 from 7? So we took 7 times 2, which would be 14, and then we minus 2 to get 12. Times 2 minus 2 is an alkyne. So this would end in YNE. This would be heptyne. All right. So now when we're doing formulas here, all right, I see the first one, ethene, ends in ENE. So I immediately know this is going to have C and H in it. F tells me the number of carbons, F is 2, and then enes are just times 2. So 2 times 2 would be 4 for the number of hydrogens. So again, knowing that ending, ene, means times 2 for the number of hydrogens is important here. All right, so last one is nonane. So as soon as I see A and E, I immediately know it's going to have C and H in it. The non part tells me that there's going to be 9 carbon. And then if it's ane, anes are always times 2 plus 2. So 9 times 2 is 18 plus 2 would be 20 hydrogens. All right, so just pay attention to the fact that these have different prefixes from covalent for at least the first 4, and then pay attention to how you figure out the number of hydrogens.